Hi everyone. This is session one of a six-part course, right? Where we'll be discussing about Python. The course has been designed specifically for network engineer roles, right? Um, Anybody can see this, right? But it's specifically the examples mentioned here are specific to network engineering, right? Um, they are applicable in general as well, right? But the if you're coming from a network engineering background, right, the examples will be easier to understand. Okay. Here we'll be starting. This is our first session, so we'll go with Python fundamentals, right? Here we'll talk about how Python works, variables, types, and control flow, right? Then in session two about data structures, in three about files, JSON, YAML, regex, right? In fourth on APIs. Okay. In five, we'll start to see some how to do real network automation, right? With NetMiko and Nornit, right? We'll take some real devices, right, in the lab, and then we'll try a few network automation on them, right? And in sixth, we'll build a kind of small project, right, where we can see how end to end, Python is working. Okay. So in the initial, at least three to four courses, right? 3 to 4 sessions. I'll be using this environment where I'm in Google Colab, right? So this environment is called as Jupyter Notebooks. Okay. So in Jupyter Notebooks, you can run Python directly in this environment itself. You don't have to install anything locally, right? So that's why I have picked up this environment because you don't need to consume time to install a lot of dependencies, right? A Python in your local environment. We'll talk about that in maybe fourth or fifth course, how to install it locally and then start with local development, right? But for the initial few sessions, right, it's good that we can directly go ahead and use it in Google Colab, right? So you can install Jupyter Notebooks locally also, but Google Colab is like a ready to go mechanism, right? I can share this link with you, and then you can directly go ahead and start using it, right? Without any time taken to do any kind of setup. Okay. So that's on the environment I'm using, right? But don't worry, I'll talk on how to set it up locally, right? Because whenever we are doing it, that development in a real environment, we'll be doing that in a real environment. This Google Colab is used also used in production, okay, in data center kind of for doing some testing and all, right? And it is also good for some machine learning and AI related tasks, right? But normally, generally in network automation, people won't be using this environment much. Okay, we can use it for some basic prototyping and all, but at the end of the day, we need to work on local development, right? In system, install it on our laptop or something and then do it. Okay, we'll talk about that in some of the later sessions. But to start with, let's go ahead and first talk about what happens when we run any Python code, right? Um, Whenever we are running any Python code, right? So when you are doing any local development, you will understand that the Python's file will end with .py. Okay, like you have .txt, right? Or you have .cfg files. Similarly, or .log files, you have similarly .py file. Okay, which says that this is a Python file. Okay, or you run anything in this notebook, it is actually working in a similar manner. Okay. So first your Python will read all your source code. Source code as in whatever text, for example, this whatever this I've written, this is the source code. Okay. So it will read all this code. It will compile it into a something called as bytecode. Okay. So we don't have to worry about what and how does that bytecode look. Okay, but we have to just understand that there is some an intermediary layer which is present. Okay. Then there is a program called as PVM, Python Virtual Machine, that executes that bytecode line by line. Okay. So PVM, you can say, is by default installed in this environment. That's why we're able to run this code directly. Okay. But when you are doing it local development, we have to install Python locally. When we are saying we have to install Python locally, right? PVM is part of that package. Okay. So PVM will help you to execute that bytecode. Okay, you don't have to understand how PVM works and everything. You have to just understand. The understanding is that PVM, when we run a code, PVM in the background will execute that. Okay? Now, as it executes, the interpreter keeps track of every value you create in the memory, keeps a namespace, right? So whenever I'm creating any variable, right, or whenever I'm running any code, okay, any part of this, right? So it will maintain the history in its own memory. Okay, it will understand what all variables I have defined till now, right? What all functions I have defined till now, and then going back, I can call that function. I can use that variable. Okay, so all that is being taken by the interpreter. Okay, which is our PVM. So one another aspect of Python is that here code is run line by line. Okay, when I say line by line, as in your first line will be executed. After that, the second line will be executed. After that, third line, fourth line. Okay. If your code has any error, say in second line, okay, then your interpreter won't go to next line. Okay, won't interpret the next line. It will stop here itself. Okay, so there are two type of programming languages. One is interpret programming language and one is compiled programming language. Okay, so some of the C, Java, those are compiled programming languages. Okay, where the whole source code is programmed, whole source code is compiled first. Okay, in Python the code is not compiled first. Okay, it is run line by line. Okay, so let's start with this example. Okay, I have stored this value. Okay, this assume that this is a switch name. Okay, I have assigned this value to this host name. Okay, this host name is a variable. Okay, so whatever is on the left side of equal to, right, is a variable. Whatever is on the right side is a value assigned to that variable. Okay, now when I see what is the value when I print this host name, right, when I print this host name, it will not print this host name, it will print its value. Okay, so it prints this value, right? It, this is a function called as type. Okay, so we'll discuss about functions not in this session, in the next session, but understand that basically this will tell us that what kind of variable is it. Okay, so this says that this is a string, class string. Okay, so this is basically a string. What are classes, that also we'll discuss in some another session. Okay, basically this is a string. Okay, and identity, I can find the exact memory address. Okay, where it is stored. Okay, this is of not much use, okay, for us normally, but I have given this, I'm giving this example to help you understand later little bit below how actually variable works. Okay, basically I will depict how mutable and immutable variables are work basically. Okay, so this is a memory address is assigned to this variable. Okay, this is done by all our PVM, and our OS operating system will take care of it. Okay, so this is a variable. Okay, and this is its value. So variable is like a box. Okay, and in that box you can put some value and then label it with something. Okay, so the host name is the label and core switch one is the value. Now ID returns a unique string. Every value you create a string, a number, a list lives somewhere in memory, and a variable name is just a pointer to it, right? So this is a little bit low level. Whenever you assign something into a variable, basically it is stored in a memory, and in your memory, that variable is just pointing to that memory. Okay, so whenever you want the value of that variable, it will take it from the memory and print it for you or give it to you. Okay, now let me take and give it. It's a host name, right? I assigned the same host name to another backup name. Okay, that means I took this variable. Okay, this is the value, and I assigned that variable to another variable. Okay, now I want to see whether this is also pointing to the same memory location or not. Okay, so what I did is host name is back name. That means I am checking whether both of these variables are same or not. Okay, and what does it say? It says true. That means both of the variables have the same value. Okay, of course, which one? Now I'm printing the ID as in the memory address of the both of them. Okay, and what I am finding is it is also true. That means both of them are actually stored in the same memory. Okay, that means when I created a backup name, right? When I created a backup name with this host name, it did not create a new memory for it. Okay, it took it and stored it in the same memory. Okay, that means I'm still pointing to the same memory. Host name and backup name are, both of them are pointing to the same one piece. Okay, so these are not two different pieces. Okay, from the memory point of view, these are not two different pieces. This is actually one single piece. Okay, host name and backup name both are pointing to the same piece of memory. Okay, so second label pointing to the exact same object, right? Every assignment which we do, okay, it does not mean that I create a copy. When I say x equal to y, does not mean that I am creating a new copy of y in x. Okay, it also makes that it always means that I am pointing to the same location. I'm saying x, you also point to the same location where y is pointing, right? So here when host name was pointing to some location, I told backup name, you go and point to the same location where host name was pointing, right? So this is very important to understand from the perspective that whether this object is mutable and immutable. Okay, I will talk about it a little bit in this session only, but a little bit later, right? But keep this in mind for now. Okay, I will talk about what are mutable and immutable. Okay, now in Python you can do dynamic typing. Okay, dynamic typing as in, before assigning value to a variable, you don't need to define what kind of variable it is. Okay, so in another programming languages, this is coming from other programming languages like C or Java, right, or Golang, where you might have to first tell that this device is a type of, is a string. Okay, and then you assign a value to it. Okay, for example, you take it from some other programming language, you will have to do it like this. Okay, 4 is a type of integer, and that we are assigning the value 22, an integer value. Okay, you in Python, you don't have to do it. You can directly assign device an integer value. Then later you can assign device and device a uh, string value. Then later you can assign the same value, same variable to a string, same variable to a list. Okay, this is dangerous. This gives us some hidden power in Python, right? But this is also a little bit dangerous. Okay, so it is better that we use one device for one variable for a single type of variable. Okay, so it's better we keep device as a string always. And remember that when I created device, it was a type of string. Okay, so later I don't want to make it a number, or later I don't want to make it, this is a list. Okay, so I don't want to make it a list or something. Okay, so that this freedom is given to the programmer. Okay, so you can see this is string, integer, and list. Okay, as I'm mentioning that this is legal, but it's a bad idea for readability. Okay, don't reuse the same name for different kind of data. Okay, make sure you name the variable also in such a manner that you understand. For example, you can rename this to device underscore string. Okay, you can name it something like device underscore str, right? Or you can mention it something like device underscore num, so that later you understand that this was one device which was mentioned as a string, and this was device underscore num. This is the number of that device. Okay, this is just, all of this is our liberty. Okay, how we want to name it, how we want to assign that variable. Okay, but remember that whenever you're programming, you have to take care that don't assign to the same variable multiple different types of data. Okay, otherwise it can lead to bugs, and it will be difficult to troubleshoot. Okay, now there are a couple of types of data types available to us. Okay, one is an integer. Okay, integer, we know full numbers. Okay, 22, 33, 45, 69, right? Whole numbers, which we can use, say, suppose for port numbers or VLAN IDs, right? Because those are full numbers, whole numbers. Then there is a float. Float is basically your 99.98, right? Decimal numbers. You can use it for, say, link utilization, right? Or bandwidth utilization, something like that. Then we have str, which is a string, basically a text. Okay, so in string you have to assign it between these, either two uh, opening and closing quotes, or a single opening and closing quotes. Okay, so whatever is present in these quotes is basically one text, one string. Okay, then there is boolean, which is mentioned as a bool here, which is basically a true or false value, right? Is my interface up, right? Is my interface taking traffic? We can assign that value a true or false, right? So that is true or false. Then there is a none type. Okay, None type is basically means nothing. It is not holding any value as of now, right? And it means that there is an absence of data here. Okay, so uh, remember that none is does not mean that it is zero, right? Or it is an empty string, or it is not false, therefore none, right? It's not like that. Okay, this is an explicit way of saying that there is no data as of now. Okay, it can have data later. Okay, we can assign a value, we can assign something a value of none first and then assign it the data later. Okay, that is how generally we'll do it in programming. Okay, so it generally means that I found nothing, that's why I'm returning none. Okay. None you will return from functions. Okay, so function is like a block of code. We'll discuss it in session 2. It is basically a block of code you write, which is reusable block of code. Okay, from that block of code you can return none. Okay, and then later match on none that whether did I receive any value from function or not. Okay, so if it is none, that means I did not receive any value from the function. If it is not none, that means I received some value. Okay, so that kind of matching you can do on none. Okay, just showing those what I showed above in code format, right? Where this is a integer, right? This has become a float. Okay, if I do 48.0, okay, this becomes a float now. Okay, because whenever we add that extra dot in the end, after that anything it becomes a float. This becomes a string. This is a boolean. When we are saying boolean, either we can assign true or false, nothing else. Okay, and true, remember the capital T should be capital. Okay, the small capital does not work. The small starting with small t does not work. Okay, it will say true is not defined. Okay, you can do something like this: true equal to true, right? And then assign that true to here. That's possible, right? I'm not going to do that. Okay, uh, true and false, both of them will start with a capital T and capital F. Okay, and this is none. Okay, again none starts with capital N, small n. This will not work. Okay, so remember about capital and small. Okay, and we don't have anything yet. If I have a backup IP later, I can assign it to it. Okay, so this we can still assign some value to it, but as of now it is none. Okay, how does this F string work? What is this F and everything? We'll talk later when we talk about string. Okay, next is our type conversion. Okay, type conversion means, see, whenever data is coming from, say, any API, right, or any device, any file, right, it might be at most of the time the case will be like it is in a form of string. Okay, so data type conversion means converting one type of data into another type of data. Okay, if it is convertible. Okay, I'll talk about what does it, if it means, if it is convertible means. So I can convert one string into integer. I can convert an integer back to a string. I can convert a string to boolean, something like that, right? So that is called as type conversion. Okay, now I got these two values, suppose say from an API, right? I got the raw boolean ID, I got the raw MTU, right? And I have printed that raw boolean ID. Okay, my what I wanted to do is I wanted to add both of them. I wanted to add the boolean ID and the MTU, right? This looks like number to us. Okay, so the output should be 1600, right? But when I added them, the output is coming as 1001500, right? Because these are strings. So when we are adding two string, we are not adding, we are doing concatenation, right? Concatenation means just attaching two strings at one end of another, right? So that's why we took the 100 and attached 1500 to it, right? So we are not doing any addition here, we are just doing the concatenation. Now, what if you want to do addition on that number, right? Because the API, I cannot go ahead and change that API, right? Because that API from can be from another source, right? So I'm getting from the API string, but I want to do addition on that, right? So I will have type, I will have to type convert them, right? So what I've done is I've converted this to an integer. Okay, I've converted this raw villain ID with raw villain ID. Added int and then in brackets. Okay, so int, this is a function. Okay, as I said, I'll talk about functions in session 2. But function converted this integer string into an integer. Okay, and this into a same thing to raw MTU, and when I added it, it got 1600. Okay. Now I was talking about one thing, that those values should be convertible. Okay, convertible as in, say I have a value of uh, 600R. Okay. And now I'm trying to convert it into an integer, right? So this will not convert into an integer because this is our common logics, right? That this R is not we cannot convert R to an integer, right? So that's why it is not convertible. When I'm saying int L, it says invalid literal for int with base 10. That means we have the base 10, we have to convert it into base 10. R cannot be converted to base 10. Okay. Once I remove this R, it can be converted. See, it got converted without any error, right? So that that data should be convertible. Okay. It is not like we can convert any kind of integer to a string or any type of string to an integer or any kind of integer to a boolean or vice versa anywhere, right? Those should be convertible with each other. Okay. And yeah, what I was mentioning here is that these kind of errors will be silent. Okay. Now silent as in, from our perspective, we thought that if these two numbers are not addable, we should get some error, right? But it did not throw an error, right? It just added them, assuming that they are string, right? It just concatenated them, right? So these kind of errors, logical errors, right, will be hidden. Okay. And we won't be able to, and this will be only visible when when we see the outputs. Okay. And we'll see that this output is is not expected, right? And then we'll go back and troubleshoot that why is this coming like this, and then we can understand it. Okay. So this is very important to keep in our mind so that we don't come into any unwanted situation, right? And have a long debug sessions. The next is mutability, which I was talking about above, right? What does mutable means, what does immutable means, right? uh, See, some type of data are mutable. Okay. Immutable. Okay. Immutable means once we have created them, we cannot change them. Okay. For example, integer, float, string, boolean, tuple are all immutable. Some types are mutable. That means we can change it. List, dictionary, and set are mutable. Okay. What do I mean by mutable and immutable? Right. What I did is I have a host name, right? I have a host name course which one, right? I printed its ID. This is its ID, right? ID as in the memory space where it is stored as of now. Then I do the hostname.upper. Hostname.upper is also some kind of function, you can say, which will capitalize that string. Okay, so at the end of the day, the string will look like this. Okay, but what we'll think, we are just assigning the host name back to hostname.upper, right? I'm not, if you remember, if you see, I'm not creating a new variable. I'm assigning it back to hostname itself, right? So we might think that it will go and stay in the same memory, right? But it is not happening like that, right? It is overwritten. Hostname is overwritten with a capital core switch one, right? But the memory address also changed. Okay. So when we are saying that this is immutable, immutable means you cannot modify it in the same memory place. Okay. If you have to modify it, you will have to take that value, modify it, and then store it in some another memory place. In place, you cannot modify. Okay. So in place, you cannot modify integer, float, string, boolean, and tuple. Okay. See the what will happen to the old core switch one? This will be still there in the memory, but will not. As I was saying, right, we cannot have access to that memory because the variable is now pointing to a new variable, right? It The same host name, the same variable we are using for the new also. Okay, but if I make this host name one, right, I will have access to both the old variable and the new variable. Okay, but since I made this host name itself the new value, we won't have access to the older value. Okay, and it will be later collected with the Python's garbage collector. Okay, and it will clean that memory later for us. Okay, so we don't have to worry about how much memory this will consume and all, right? This is and the Python will collect and clean it. Okay, but uh, uh, we have to remember or understand that we don't have to use why to understand about mutable and immutable. First, it can cause some kind of weird issues where we might think that we have changed this, but actually it was not changed, right? It is changed in the same place, right? We will think it like that, but actually a new way, no, it is assigned to a new place. Okay. And second thing is, we don't want that we do multiple assignments of the value, right? And then we are using innumerable new variables without counting how much memory space we are using. Okay, so um, now list on the other end is mutable. Okay, so when I'm this is my list. Okay, what are lists and everything we'll discuss in later, right? But this is a list, okay, and this is stored in this memory, right? And when I added a new interface to this interfaces list, right, it does modify it in the same place, right? After also the memory address is still same, right? So you understand that uh, these three data structures like list, dictionary, and set, they are mutable in place. Okay, so you are modifying it in the same memory. Okay, you remember, right? Earlier we did x equal to y, correct? Now there we did it with string. Okay, so when we are doing x equal to y, that means uh, x and y both were pointing to the same value, right? But here we are doing it with a list, right? And we have primary inventory and we have say backup inventory, correct? Now I modified the backup inventory, correct? But since this is happening in place, right? My primary inventory also got changed, right? See, both of them got changed later, right? So this there here we are using both of the concepts, right? The first concept where I said that when you are doing x equal to y, actually x and y both are pointing to the same location, right? But now because this is in this data structure is mutable, right? When I modified the y, that is the backup inventory, my primary inventory, which was also pointing to the same location, that also got modified. Okay, this can cause a lot of errors. Okay, in a while we are programming it in a real scenario, right? We have to remember and keep it in our mind, right? What all variables were assigned where, and now if I'm changing it in the backend or in the earlier code, how will it reflect, right? And will it change the initial assignment also? Now, what to do if I want to just make a backup inventory means that if I'm modifying the backup inventory, it should not touch the primary inventory, right? So I can create a copy of it. Okay. So the backup inventory, I created a copy of the primary inventory dot copy, right? And now when I'm appending it to backup, it is not modifying the primary. Okay. This you can understand from one another example. Say I have a primary configuration where I have the configuration from say from a router, right, in the form of a list, right? Suppose say it's like primary conf, right, where I have something like conf t, correct, and I have something like int uh, hu0/1, right? I'm just randomly end, right? Something like this. You got this configuration from your some configuration portal, right? Downloaded into your through some API in your Python, right? Now you create a secondary config, right? A backup config, you can say something like that, right? Backup conf. Now, when I'm creating the backup conf, right, my thought process is my primary conf or whatever modification I'm doing in the prime backup conf should not touch my primary conf, right? Because primary conf, suppose you're saying is you're saving it as a rollback, right? If something goes wrong with the backup conf, I will go back to my primary configuration, right? But since you will modify the backup configuration, primary configuration will also get modified. Okay. So here you will have to do dot copy, right? You go ahead and modify your backup configuration, your primary configuration will be untouched. Okay. At the end of the day, if your backup configuration is working, you will use backup configuration. If say some error is coming, you can again roll back to primary configuration, right? So this is kind of a real scenario where this kind of you know logic will have to be used. Okay. Now then there are some arithmetic operators, right? We talked about earlier also addition, multiplication. We talked about addition, right, where concatenation was happening on a string, correct? So we have other type of arithmetic operators also. For example, say I have a subnet bit of 24, right? I'm doing minus here, subtraction. right? This is an exponentiation. This is a subtraction. Okay, exponentiation means uh, 2 raised to something, right? 2 raised to 5, 2 raised to 6, right? Generally, what we do it like this, right? 2 raised to 8, right? So instead of this raised to sign, right? This sign we replace it with this double star in Python. Okay, this is both of them are basically same. Okay, now there are three types of division actually in Python or in most of the programming languages. Okay, one is true division. True division means it will always return a float. Okay, that means it will return the exact value. Okay, this is a floor division. Floor division means it will only return you the uh, floor part. It will not return you the whatever is after the dot. Okay, so basically it will always return an integer. Okay, and this will return you a what you can say the remainder. Okay, so this from this value it is not this example it is not very much understandable. Okay, so let me first divide 64 by 3, right? If I divide 64 by 3, I will have some integer and I will have some decimals, right? So if I divide it 64 by 3 directly, I will have this in a decimal format, right? 21.333, whatever is there, right? But I want that I don't need this dot 3332. It's fine if I just get slash if I get 21, okay? The floor value. So what I will do is I will do it like this. Once I do it like this, I am only getting the floor value. I will not get the entire 64.3. Okay, so let me print it. Uh, It's a little bit difficult to edit, but yeah. So yeah, 64 3, right? This is 21, correct? Now I want that I should get this 21 also, and I should get the remainder also, right? So what I'll do is I'll use the third way of division, which will give me the just the remainder, right? This is me giving me the remainder, right? So when I divide 64 by 3, it will come 23, right? And it will give me 1 as a remainder, right? So that's what all these three type of division mean. Okay. Now there are two types of uh, you can say comparison operator, right? One is equal to and one is. Okay. So when I say is A and B same, right? I know that when I do A is equal to something, this A is assigned a one memory location, right? When I do B is equal to something, this is assigned to memory location also. Okay, both of them have the same value, but both of them are different variables, so they are assigned to different memory spaces, right? So when I do A equal to B, I am just checking the value, okay, and therefore it is coming as true because both of them have the same value, right? But when I am doing A is B, it is giving false because it compares the identity. Identity as in it compares that whether A and B are in the same memory location. Okay. Now what I will do is I'll assign C is equal to B. Okay. Now I know that C and B are both pointing to the same memory location, right? And I will do print C is B. This will come as true, right? Because C and B both are pointing to the same memory. Okay, so this is done for checking memory integrity. Okay. Now, what I've done here is I have assigned backup IP is equal to none. Okay, and I am checking is backup IP none. Okay, I can do equal to also. Okay, but this is more like more preferred way to do it. Okay, whenever you'll see and read the code, right? Most of the places it will be done like this. Okay, equal to also works, but this is an idiomatic way of doing it. Okay, idiomatic as in a preferred way of doing it. Okay, a shorthand something kind of. Okay, so yeah, that's where the important point is equal to checks value is checks the is exact memory. Okay, now we have logical operators and short circuit evaluation. Okay, so we have some logical operators like and or not. Okay, these are normally we call as boolean expressions, right? So one important concept is that Python evaluates all this lazily. Okay, lazily as in it short circuits. Okay, we know that if we are doing false and true, right, it will come as false, right? So when Python sees that my first value is false, right, it directly determines that the output is false. It does not need to check what is after and, because after and, if it is true or false, the value is false, right? But if I'm taking an or operator, right, the first value is false, even then I have to check the second value to understand whether it is false or true. Then only my solution, right, my last value, the final result is dependent on the second value also, right? So this short circuiting mechanism is important to understand because it affects our code in a very unique manner. Okay. For example, here I'm doing if IP in device, right? IP is not there in this device, right? So it will short circuit here. It will not do this. It will not run this. Okay. That's what I was saying, short circuit. As soon as it sees that this condition is false, it does not go and run the second part. Okay, it says print management network detected. Okay, but if we do it otherwise, right, device IP starts with 10.0 and IP in device, this code will not work because there is nothing device IP in this dictionary. There is nothing called as IP, right? There is nothing IP, right? We'll discuss about dictionary also, but as of now there is nothing called as IP in this dictionary, right? So without checking the IP, if I'm fetching the value of IP, it is doomed to fail, right? So here it will fail. And therefore, what I did is I first search whether there is an IP in this dictionary. If there it is a if there is an IP, fetch that value of that IP. Okay. So whenever you are doing any safety check, okay, order is very important. Okay. You have to guard the condition first and then do the risky operation second. Okay. So it happens depends, right? Whether you're using and or the short circuiting mechanism is very different, right? But as I was saying, right, in all the logical operators, this short circuit thing will happen. Okay. Now, uh, when we are checking the truthness of any value, right, where we were saying, is this value, right? Uh, we have to understand that in Python, right, any object can be true or false. Okay, it is not like the true or false will be you have to assign it manually. Okay. For example, 0 will be considered as false, right? Because 0 in boolean will be, when we are typecasting 0, it will convert to false, right? 1 is true, -1 is true, empty string is false, anything we have in string is true, this is false, true, false, true, false, right? This is common and common understanding, right? From our understanding we can understand whatever is an empty value is basically false. If it has some kind of value, it is true. Okay. So whenever, if you want to understand whether a list is empty, right, or a string is empty, you can directly say is true, is false, right? If this is true, if this is false, you do some conditions, right? I will talk about if and else also below, but this like this, you can test the truthness of some value. Okay. Now, strings are an important part, right? Because most of our CLI configuration, API responses, right? Most of our part we were dealing with strings. Okay. String parsing and is an important part, right? Because whatever data we are getting from the device CLI, that will come as a string to us. Okay, we have to parse and get the IP address, or parse and get the specific details, right? Whether BGP is established state or something like that from the string. How to do that? Doing that is important part, right? So something there is a concept of we will not discuss everything about strings here, right? String is a big concept, but I'll discuss most of the concepts which will help to start that exploration, right? So we in string we can use something called as indexing, right? So indexing works. We have three values in indexing. Okay, start, stop, step. Okay, at what index I have to start, till what index I have to get the value, and how many can I skip with each within each pass. Okay, remember that indexing starts at 0. Okay, So indexing your first value in the string, okay, this is G0 basically, okay. G starts from 0, I is 1, so your counting starts from 0, okay. And if you're counting from -1, you're counting actually from last one. This is -1, this is -2, -3, -4, okay. So minus counting starts from the end, okay. Most of the other programming languages, okay, will not have minus counting in lists, okay. But in Python, we have this unique feature. Okay. So now getting from that data, when I say interface of 0, I am saying actually I mean G. When I say interface of 1, I mean I. Interface of 2 is small g, right? But now when I go from the last, when I say interface of -1, it is actually 1, right? This value. When I say interface of -2, it is this slash. When I say interface of -3, it is 0, and so on and so forth, right? When I'm saying I want the value of interface from 0 till 9, that means I have to take the value from 0, right? So G0, 1, 2, 3, 4 until 9 I will go. Okay. So when I'm saying 0 to 9, those are 9 characters, but it will end till counting 8. Okay. Up to 9. And this means that starts from index 9 to the end. Okay. So as I was saying, this means start, this means stop, and this means step. Okay. And using this functionality, there is an easier way to reverse a string. Okay, in Python. In another programming languages, there are different ways to reverse a string. In Python, it is very easy to reverse a string. Okay, you can just do dot dot minus, that will reverse the entire string. Okay. Now for parsing output, okay, real output, I will show you some functions, right? So this is my line, for example, which I got from say a CLI parsing, right? So I did raw line dot strip. Okay. Raw line dot strip, what it will do is it will strip all the empty spaces, including white spaces. Okay, empty spaces leading and trailing. Okay, not the spaces in between. Okay, so you can see all the starting and ending spaces are trimmed. Okay, then split will split on any white space. Okay, it will give you a return. It will return you a list. Okay, so I have three values here, right? And between them there are white spaces. Okay, so I can say gigabit ethernet 0 up up. This is what I found, right, when I did a split. Okay, you can put some other type of other you can split on something else also. For example, you can split on comma. Okay, you can split on other things also. I will not go deep dive into split. Okay, but you can start from here. Split basically splits on some specific keyword. Okay, so when I say split on nothing, that means it splits on white space. Okay, so that's why we are getting gigabit ethernet 0 1 up. Okay, we can unpack the list. Okay, so we know that we have three values in this list, so I can unpack this like name status protocol equal to parts. When I do this, these values are unpacked. Okay, but what if I only give two values? Okay, it will say too many values to unpack. Okay, we know that this list has three values. Okay, but I am only giving it two values, so how will it unpack it? Okay, it is not able to unpack it. Therefore, I have to give it three values. Only then it will be able to unpack. Okay. Name dot lower, understood that it will make everything lower. Starts with, does my string starts with gigabit? Okay. Name dot replace. Replace means I have to replace this gigabit Ethernet keyword with GI. Okay. This is a very normally used thing in automation. Okay, where I have to replace this gigabit Ethernet with GI. Okay. For example, in different automation like Juniper, Cisco, or Arista, right? The interface naming is very different, right? And I want to make them all in the same format, correct? For naming, I can use replace there. Okay, and this is join. Join basically will join on some specific keyword. Okay, so I have these to join, and between them I'll put dash. Okay, these are important ones. There are many other string uh, functions which are present. Okay, but I've started with the major ones. Now f string, okay, f string is used to build string from a variable. Okay, that means I want to create a string out of it. For example, I have interface, I have host name, I have VLAN, right? And I want to create a single I have to create a single config, what you can say, a config line out of it. Okay, a single string. So what I did, I started with f interface, and between this f only I can add this open and closed curly brackets, and I can add interface name here, I can add VLAN name here, I can say I can do anything related to Python here. I can say hostname.upper, hostname.lower, anything here. Okay. So you can see how I use utilization also, right? Now I was mentioning, right, strings are immutable. So whenever you are creating or modifying the string, right, you are actually creating a new one. Okay. So string you cannot modify in the same place. Okay. So whenever I am doing any modification on the string, I am actually modifying and I am creating basically a new space in the memory. Okay. It is immutable. Okay. It is not like for example, whenever I am doing it like this plus equal to, right? Uh, like this, right? So we are creating actually a new space in the memory. Okay, this is not the exact same space. Okay, so one design, um, yeah. Uh, so um, uh, right after strings, let's start with control flow, right? So in control flow, right, what we'll talk about is if and else statement, right? So control flow is basically to make decisions. Okay. Now I have some values. Now based on that, those values, based on those variables, right, I want to take some decision, right? How to take that decision, right? So this is a function. We'll talk about functions later in next session. Okay. But just understand this is a function, a reusable part of code. Okay. And here what I'm saying, if percent is greater than equal to 90, okay, I have some percent value, a variable, right? I'm saying if percent is greater than equal to 90, it is critical. Okay. Say this is a utilization, right? Utilization of a link. I'm saying if the link utilization is more than equal to 90, it is critical. If it is more than equal to 75, you see greater than equal to, that means even if it is 75, it is warning, right? So between more than 90% critical, between 75 to 90, warning, right? Because if it is greater than 90 or equal to 90, it will go and match this. Okay. Once it matches this, it will don't not move ahead. Okay. That's why I mean if else if, this is basically else if, but in Python you will use elif. Elif means else if. Okay. If it is more than 90%, you return directly from here. Okay. You will not move ahead. Okay. Else if percent is greater than equal 5. If percent, else if percent is equal to okay, is greater than equal to 0, it's okay. Okay. Otherwise, catching everything else, it is invalid. Okay. Maybe say it is a negative number or somebody passed a string, right? So that will catch and call it as invalid. Okay. So you can see 45, okay, 76 warning, 95 critical, and -3 it's invalid, right? As I was saying, else if conditions are checked in order and Python stops at the first one, that is true. After that is not checked. Okay. If you want to have, if you first if you said if percentage is greater than equal to 0, return okay. Okay, it will go black, it will block there itself. Okay. So it's important that you put the bigger number greater than equal to 90 first. Okay, it is not like you can put greater than equal to first and greater than equal to 90 later and assume that it will match at greater than equal to 90. No, because any number which is greater than 90 is greater than 0 also. Okay, so understand that will block there itself. Okay, it will return okay and just block it there. Okay, and we can combine these conditions. Okay, so say I have admin status, right? I have line status, right? Admin status and line status, right? Basically the admin status of it, of the link, and the what is the actual status, right? Of the link, right? Whether the link has any issues or not, correct? So I can do if admin status is equal to up and line status is equal to down, right? Then it is false, return true. That means I have to check it. Okay. That means admin is up, but line is down. If admin is also down, line is also down, that means I've shut down the link manually, right? So no need to worry. That's from assuming our example, right? So that's why I'm returning true. If admin status is up and means plus, right? And both of them are true, then only I'll return true. Okay. If this is false, if admin status is down, right, it will not check this and directly return false, right? That is what I was mentioning about short circuit earlier. Okay. So that is what the output given here, right? Now we have something similar called as loops. Okay. Loops will iterate over a known collection. It will iterate over collection. Okay, we'll talk about data structures again in next session. There we'll talk about, again about loops. Okay, understand this from here. We are taking the basic understanding. Okay, what does loops mean? Okay, so I have this string, I have this list. Okay, and this list I have all the values. Okay, I want to access all of these values one by one, right? For example, I want to access this first, then this, right? Therefore I have given 4 device and devices. Okay, so device will hold the value. First it will hold this value. After I printed, it will hold this value. After I printed again, it will hold this value. That's what I'm getting. Core switch 1, core switch 2, core switch 3. Okay, similar, there is another while loop. Okay, in while loop you do not you will have to give condition. Okay, you don't, it will continue to loop till some condition is met. Okay, so I have uh, try to connect it, right? And I am saying attempt is less than max attempts and not connected. Okay, that means still I am not connected to this device. You continue connecting it until I have the max number of attempts. That means I will try to connect with the device 5 times. If it is not connected, I will just throw an error that I am not able to connect it, right? Giving up after this number of attempts, right? Now, say you have to break and continue, right? Break and continue are two constructs which we can use with for loop also, right? Which we can use with while also, right? Now, I have said for interface in interfaces, right? If interface is equal to target, I would say found this interface, break, and otherwise continue looking into it. For example, I have this list of interfaces, but I want to see whether do I have GI03 not in it or not, right? So I am matching on everything, right? I matched on this, no. I matched on this, no. I matched on this, yes. I printed it, right? I can continue matching on others also, right? But you think that maybe it's a very big network with thousands of devices. You have maybe say thousand of interfaces, right? If you continue looping over it, even if I found that value, right, it will cost resources. It will take time, right? Better. What I did is once I found that interface, I broke out of it. I broke out of this for loop. Okay, that means no need to check further. Okay, exit the loop immediately. Skip the remaining items. Okay, this means continue means you skip this iteration, loop continue with the next. Okay, so what I'm saying is if you see G01, okay, then print it. If you see G02, no need to print. Okay, continue, but don't exit as of now. Okay, if I see G0.3, I will print it because it is not in this list. If I see G0.4, I will not print it because it says continue. Continue means skip this iteration. Okay, so these are break and continue. Okay, now uh, I will leave with a problem statement. Okay, and I will discuss about the solution of this problem statement in the next session before starting the next session. Okay, but I will explain what is the problem statement. Okay, you will have the problem statement here in this Python notebook. Okay, which I'll share with you. But your problems, you try to solve it on your own. Okay, using whatever we have learned today. We will discuss about the solution in the first thing in the next session. Okay, then we can match it whether you used it correctly or not. Okay, so you are given a raw output of show interface. For example, you are given this output, right? This is common output, right? Where you get the interface name, you get the conf status, then the line status, then the I think this is your MTU. Okay, admin status, line status, and MTU. Okay, this is what you are getting when you are supposed to run. You are running show interfaces. This. Okay, so you got these outputs. Okay, now what you have is you have to loop over all of these lines. Okay, and you have to parse each of this line and get first split it into 4 parts and get all the values. For example, you have to get interface name, admin status, line status, and MTU. First thing is you have to get all these 4 values from all these uh, you will get a list. Okay, so for example, you will get like a list, like list like this. Okay, you this list you have to first loop over this list and get all these values. Okay, then you have to classify, you have to convert your MTU. Your MTU will come in as a string, right? You have to convert it into an integer, and then you have to check it, is it on okay, cabling status, disabled or unknown. Okay, based on this if statements. Okay, you move it in any one of these if statements. Okay, and you have to keep account of how many interfaces are there in each category. Okay, say these are 5 6 lines, how many of them are okay, how many of them are cabling, how many are disabled, how many are unknown. Okay, I will show you the output, how output will look like, not showing you the exact code. Okay, but you see this will be like output where you will show G0/0. Okay, admin is up, line is up, empty is 1500, so it is okay. Admin up, line down, empty 1500, so check cabling, right? And at the end, I counted both, two of them are okay, right? One of them is in check cabling, one unknown, one disabled, total five, right? So I counted how many total, how many are in each one of the class, and I printed the exact classes also. Okay, this is the solution. We'll discuss the solution in the next session. Yeah. Thanks for watching this video, and remember that we will have 5 more videos coming up. So yeah, stay tuned. Thank you.